In statistics, exploratory data analysis, EDA, is an approach to analyzing data sets to summarize their main characteristics, often with visual methods. A statistical model can be used or not, but primarily EDA is for seeing what the data can tell us beyond the formal modeling or hypothesis testing task. Exploratory data analysis was promoted by John Tukey to encourage statisticians to explore the data, and possibly formulate hypotheses that could lead to new data collection and experiments. EDA is different from initial data analysis, IDA, which focuses more narrowly on checking assumptions required for model fitting and hypothesis testing, and handling missing values and making transformations of variables as needed. EDA encompasses IDA. Overview. Tukey defined data analysis in 1961 as procedures for analyzing data, techniques for interpreting the results of such procedures, ways of planning the gathering of data to make its analysis easier, more precise, or more accurate, and all the machinery and results of mathematical statistics which apply to analyzing data. Tukey's championing of EDA encouraged the development of statistical computing packages, especially S at Bell Labs. The S programming language inspired the systems S+ and R. This family of statistical computing environments featured vastly improved dynamic visualization capabilities, which allowed statisticians to identify outliers, trends, and patterns in data that merited further study. Tukey's EDA was related to two other developments in statistical theory, robust statistics and nonparametric statistics, both of which tried to reduce the sensitivity of statistical inferences to errors in formulating statistical models. Tukey promoted the use of five-number summary of numerical data, the two extremes, maximum and minimum, the median and the quartiles, because these median and quartiles, being functions of the empirical distribution, are defined for all distributions, unlike the mean and standard deviation. Moreover, the quartiles and median are more robust to skewed or heavy-tailed distributions than traditional summaries, the mean and standard deviation. The packages S, S+, and R included routines using resampling statistics, such as Kanui and Tukey's jackknife and Efron's bootstrap, which are nonparametric and robust for many problems. Exploratory data analysis, robust statistics, nonparametric statistics, and the development of statistical programming languages facilitated statisticians' work on scientific and engineering problems. Such problems included the fabrication of semiconductors and the understanding of communications networks, which concerned Bell Labs. These statistical developments, all championed by Tukey, were designed to complement the analytic theory of testing statistical hypotheses, particularly the Laplacian tradition's emphasis on exponential families. Development. John W. Tukey wrote the book Exploratory Data Analysis in 1977. Tukey held that too much emphasis in statistics was placed on statistical hypothesis testing, confirmatory data analysis. More emphasis needed to be placed on using data to suggest hypotheses to test. In particular, he held that confusing the two types of analyses and employing them on the same set of data can lead to systematic bias owing to the issues inherent in testing hypotheses suggested by the data. The objectives of EDA are to suggest hypotheses about the causes of observed phenomena, assess assumptions on which statistical inference will be based, support the selection of appropriate statistical tools and techniques, provide a basis for further data collection through surveys or experiments. Many EDA techniques have been adopted into data mining, as well as into big data analytics. They are also being taught to young students as a way to introduce them to statistical thinking. Techniques. There are a number of tools that are useful for EDA, but EDA is characterized more by the attitude taken than by particular techniques. Typical graphical techniques used in EDA are box plot, histogram, multivariate chart, run chart. Pareto chart, scatter plot, stem and leaf plot, parallel coordinates, odds ratio, targeted projection pursuit, dimensionality reduction, multidimensional scaling, principal component analysis, PCA, multilinear PCA, nonlinear dimensionality reduction, NLDR. Projection methods such as grand tour, guided tour, and manual tour. Interactive versions of these plots. Typical quantitative techniques are median polish, trimean, ordination, history. Many EDA ideas can be traced back to earlier authors, for example, Francis Galton emphasized order statistics and Schwann tiles. Arthur Lyon Bowley used precursors of the stem plot and 5-number summary. Bowley actually used a 7-figure summary, including the extremes, deciles, and quartiles, along with the median. See his Elementary Manual of Statistics, 3rd ed., 1920, p. 62. He defines the maximum and minimum, median, quartiles and 2 deciles as the 7 positions. Andrew Ehrenberg articulated a philosophy of data reduction, see his book of the same name. The Open University course Statistics in Society, MDST 242, took the above ideas and merged them with Gottfried Noether's work, which introduced statistical inference via coin tossing and the median test. Example: findings from EDA are often orthogonal to the primary analysis task. To illustrate, consider an example from Cook et al. Where the analysis task is to find the variables which best predict the tip that a dining party will give to the waiter. The variables available in the data collected for this task are the tip amount, total bill, payer gender, smoking/non-smoking section, time of day, day of the week, and size of the party. The primary analysis task is approached by fitting a regression model where the tip rate is the response variable. The fitted model is tip_rate equals 0.18, 0.01 times party_size. Which says that as the size of the dining party increases by 1 person, leading to a higher bill, the tip rate will decrease by 1%. However, exploring the data reveals other interesting features not described by this model. What is learned from the plots is different from what is illustrated by the regression model, even though the experiment was not designed to investigate any of these other trends. The patterns found by exploring the data suggest hypotheses about tipping that may not have been anticipated in advance, and which could lead to interesting follow-up experiments where the hypotheses are formally stated and tested by collecting new data. Software. Cornerstone, an EDA package. Data Applied, a comprehensive web-based data visualization and data mining environment. GGobi is a free software for interactive data visualization. JMP, an EDA package from SAS Institute. NIM, Constance Information Miner open source data exploration platform based on Eclipse. Orange, an open source data mining and machine learning software suite. Python, an open source data mining and machine learning programming language. R, an open source programming language for statistical computing and graphics. Together with Python, one of the most popular languages for data science. SOCR provides a large number of free online tools. Tinkerplots, an EDA software for upper elementary and middle school students. Weka, an open source data mining package that includes visualization and EDA tools such as targeted projection pursuit.
Please subscribe and thanks for watching.